Hi everyone, this is Chapter 12, Introduction to Probability. We're going to begin this unit by going over some key terms that you will likely encounter in this chapter. So first, what is probability? Probability is the chance that something will happen or how likely it is that some event will occur. Some events are measurable with a numeric value. If you take a look at this probability line below, I might say that there is 0% chance of an event to happen, or I might say that there is 100% chance that an event is going to happen. If an event cannot be measured with a numeric value, I might use words such as impossible, unlikely, even chance, likely, or certain to describe its probability. A trial or experiment is a situation or process that can be repeated an infinite number of times and lead to a result. So my trial or experiment could be the act of rolling a die or tossing a coin. The event refers to all the possible results of a trial or experiment. So if I were to toss a coin, one possible event would be that it would land on heads. The only other possible event is that it would land on tails. The outcome is the actual result of a single trial or experiment. It tells you what actually happened. When I tossed that coin, did it land on heads or did it land on tail? The theoretical probability is a number between 0 and 1 that indicates the chance or likelihood of an event happening based on mathematics. This is what we would expect to happen. You can find the theoretical probability by taking the number of favorable outcomes divided by or over the total number of possible outcomes. So taking a look at the spinner, if I were to ask the question, what is the theoretical probability of landing on a red? Well, I can only land on the red one way, which is if the spinner lands in this red space here. That's the number of favorable outcomes. The total number of possible outcomes is what could happen when I spin the spinner. It could land on the red space, the purple area, or the yellow area. There are 3 possible outcomes. So the theoretical probability of spinning a red would be 1 over 3. The experimental probability is a number between 0 and 1 that indicates the likelihood of an event based on what actually happens. An experiment is conducted, and the occurrence of an event is recorded. I could also find the experimental probability mathematically using this formula here. After conducting the experiment, I would take the number of times that an event occurs and then compare it to the total number of trials. So if I were to ask the same question as before, this time calculating the experimental probability, so I would spin the spinner 3 times. That would be the total number of trials. And then of those 3 times that I spun the spinner, I landed on the red 2 times. The number of times that it lands on the red is 2. So my experimental probability is 2 out of 3. As more trials are conducted, the idea is that the experimental probability becomes closer to the theoretical probability. The tree diagram is a tool that displays all the possible outcomes of an event. Each branch represents a possible outcome and can be used to calculate the probability of possible outcomes. So this tree diagram shows all the possible outcomes of tossing a coin 2 times in a row. Your first toss, you could land heads, and your second toss, you could land heads again or tails. If your first toss was a tail, your second toss could land heads or it could land tails again. So this tells us that there are 4 possible outcomes of tossing a coin 2 times in a row. You could land heads first and then heads again, heads first and then tails, tails first and then heads, or tails first and then tails again. The results of the experiment or trials could be presented in different ways. you could use a broken line graph, which is usually used to show that the information is connected in some way, usually as time goes by or as something else changes. This broken line graph compares the number of rolls to the number of times the person rolled a 6. If I were to take a look at the first 5 rolls, this graph tells me that after 5 rolls or 5 trials, they rolled a 6 one time. This plateau tells me that after 5 more rolls, there was no change to the number of times they rolled a 6, meaning they rolled a 6 0 times. They did not roll another 6 until after they rolled the die 15 times. A histogram is used to show the frequency of data using bars. As you know, even though they look similar, histograms are different from a bar graph. This histogram compares test scores out of 50 to the number of times a certain score occurred. So this histogram would tell me that the number of times a student or a person achieved a test score somewhere between 10 and 20 out of 50 is 1. The number of times that someone achieved a score between 20 and 30 out of 50 is 4, and so on. Here's your work for today. It's in your textbook, page 401, numbers 1, 3, and 7. Thank you for watching.